This is part 2 for lesson 8.1, simplifying radicals. In this part of the lesson, we are going to talk about multiplying, adding, and subtracting. Usually we do adding and subtracting first, but with radicals, multiplying is the easiest one, and so we're going to start with that. When you're doing operations with radicals, if a and b are real numbers, and that's all you know right now, so real numbers are what we're dealing with, then when you have the square root of a times the square root of b, that's the same thing as the square root of a times b. And I mentioned that in the previous video when we were simplifying our radicals. So that's something that we can use to our benefit. If you look at example 2, it says square root of 5 times square root of 15 is the same as the square root of 5 times 15, which is the square root of 75, and then you can break that down differently. And the reason why we would want to break it down differently is because if we rearrange our numbers, then we've got the square root of 25 times the square root of 3, which is 5 square root of 3. If you study example number 3, if you look at what you have with the radicals, you have the square root of 5 and the square root of 15, so those can both go underneath your radicals. The 2 stays outside. And there's really, if you think about it, there's really a 1 right there. So you're going to have 2 times 1, and that's where this 2, and it just stays there. Now once you have your square root of 25 and you bring out the 5 times 5, you're going to have 2 times 5. So let's do some practice with those. It's a lot easier to see as you do many examples. So in number 20, I've got the square root of 12 times negative square root of 24. So think about your coefficients. I mean, they kind of work like if you had, well, let me show you a different example. If you had something like x times negative 2y, and you multiply that together, you would do 1 times negative 2 and then x times y. And so radicals work the same way. You have kind of like a coefficient number, and that's the number outside the radical. And you deal with those together. So like this 1 and this negative 1, we're going to multiply those together and get negative 1. Then what's inside the radicals, I'm going to put those together. So 12 times 24. Now you can get your calculator and find out what 12 times 24 is, but we really don't care, because what I'm going to do is I'm just going to break them down anyway. So 12 is 2 times 2 times 3, 4 times 3, and then 24 is 4 times 6. And so if I look at that, now let's just look for pairs. I see a pair of 2's. I see another pair of 2's. I see a pair of 3's. So what I'm going to have outside my radicals, I have my negative 1 times 2 times 2 times 3. And then inside my radical, I have this 1, 3 that's left over. Oh, just kidding, that's not left over. The 2 is the only thing left over. That's going to go down here. That's why it's good to write the numbers in order so you don't miss anything, but that's how that would work. So then to simplify my answer, I'm going to multiply all of that together. So that's going to be negative 12 square root 2. And that's the simplified version of the question. So when you multiply this, you're going to simplify it. So square root of 20 times square root of 5. The mistake that people make is they think, well, square root of 20, and so I'm going to do like 2 times 5, that's square root of 20, and then square root of 5, and they can take out a pair of 2's, and then have square root of 5 times square root of 5, and they might think, oh, well, that's 3 square root of 5. But remember, you're multiplying. So it's going to be 2 times 1, and then square root of 5 times square root of 5 is the square root of 25. What's the square root of 25? And so the answer to that is 10. So that's one way to look at that. Another way that you can look at the same problem is by saying 20 times 5 is 100. That's something that's common to know. There's 20 nickels in a dollar or something like that. Square root of 100 is 10. One thing that you want to remember when you're dealing with radicals is remember that if you have the square root of x times the square root of x, that's the square root of x times x, or x squared. And the square root undoes the square. They kind of like cancel each other out. So if you have the square root of 5 and you square that, the square and the square root cancel each other out and you're going to get 5. And so it's kind of like adding and subtracting. One of them undoes the other one. Multiplying and dividing. Square and taking the square root undo each other. So anyway, the answer to 21 is 10. Okay, I want you to pause the video and see what you can do with 22 and 23. There are some variables in 22, so if you feel like that's a little bit too overwhelming, do 23 first, and then try 22, but come back and make sure that you get it right. Okay, for number 22, I'm going to just take everything in the radicals, I'm going to put it under one big radical. So 24, I'm going to break that down, so that's 4 times 6, So let me write 4 times, and then since it's times 6 and I see that there's a 6 right there, I'm going to put the 6 from that one right there, and then I'm going to put that other 6. And the reason I do that is because if I can take out a pair of 6s, I would rather do that than take out a pair of 2s and a pair of 3s. A to the 3rd power, and that's from right here. And then I've got A, and then I've got B to the 3rd power. So now look for my pairs. I've got a pair of 2s, pair of 6s, pair of A's, another pair of A's, a pair of B's, and this guy is left under there. So I'm going to be left with 12a to the 2nd b times the square root of b. And that would be my simplified answer. On number 23, the square root of 12 times the square root of 12, there's a couple ways you can look at that. That's the square root of 12 squared. It's the square root of 12 times 12, so you have a pair of 12s that come out. You can say the square root of 144, which you know what that is. So no matter how you look at it, the answer to that is 12. Okay, try 24 and 25 and see if you can figure out how to do those. With 24, you have negative 1 square root of 5 times 1 square root of 5. So you're going to say negative 1 times 1 is negative 1, and then square root of 5 times square root of 5 is the square root of 25, which is 5. And so negative 1 times 5. So that's one way you can look at that. You could also look at it as the negative 1 times 1 is negative 1, and then you've got square root of 5 times square root of 5, so square root of 5 squared. So that's negative 1 times 5, which is negative 5. Okay, number 25, I'm going to do 2 times 8, so that's 16, and then I'm going to have square root 6 times square root 6. So you can say 16 and then square root 6 squared, or you could say 16 times the square root of 6 times 6, which is 36. But no matter which way you do it, you're going to have 16 times 6, and so then you'll just figure out what that is. And so I'm getting 96 for that. Okay, now the next part we're going to add and subtract. So before we get into that with the radicals, let's review when we were doing like terms. So if you had 3x plus x, then that was 4x. If you have 5 apples plus 3 apples, that's 8 apples. It's not 8 apples squared. Okay, so you've got to remember that when you add, that's different than when you multiply. Same thing with subtracting. If you had, 8 monkeys and you subtract 2 monkeys, then you have 6 monkeys. So when we did like terms, that's how you're doing it. And so radicals, the great news is they work very, very much the same. So we are going to look at a couple examples first. So example 4, you've got square root of 3 plus square root of 3 plus square root of 5. Since these are the same thing, I've got 1 square root of 3 and 1 square root of 3, which makes 2 square root of 3's, plus square root of 5. Because the radicands are not the same and I'm adding, I cannot do anything else. It's like if you have 2y plus z, you can't do anything with that, so you're done. Okay, let's look at example number 5. So that says 2 square root of 3 plus 3 square root of 3 plus square root of 12. So first of all, look at the square root of 3's. I've got 2 of them and I've got 3 of them. That makes 5 of them. Okay, and that's where I'm getting that part. Now the square root of 12, I can simplify that. So remember, square root of 12 is 4 times 3, so I'm going to take that out. So I've got another 2 square root of 3. So what I have is I have 2 square root of 3 plus 3 square root of 3 plus 2 square root of 3. That's really what the problem is. So I'm going to have 2 of them and 3 of them and 2 of them. So that's 7 of them, 7 of the square root of 3. So that's how you would look at that. If you think of them like how you would deal with variables, that sure makes it a lot easier. Okay, number 6, example 6, it says the square root of 3 and then times the quantity. So we're going to be multiplying, distributing, and then we'll have to simplify by adding or subtracting. So when I do this, I'm going to do square root of 3 times negative 4 square root of 3. So square root of 3 times negative 4 square root of 3. We're multiplying. So I'm going to do 1 times negative 4 and then square root of 3 times square root of 3. So that would give me negative 4 times 3, so that's negative 12. Then I'm going to do square root of 3 times square root of 10. So that's going to be square root of 3 times the square root of 10, which is the square root of 30. If you try to break that down, you're going to get 3 times 2 times 5. There's no pairs, so there's nothing else I can do. So what that's going to come out to be is just square root of 30. There's nothing else I can say about that. This would be my simplified answer. Now, something that students are always curious about is it okay to write that, or should I write this? It doesn't matter. Generally, we usually see the radicals at the end, so if you have like a constant or an integer and a radical, you would write the radical last. If you have something like we have in example 4, 2 square root 3 plus the square root of 5, that's exactly the same as if you write square root of 5 plus 2 square root 3. Doesn't matter which one? No, not particularly. I would just say go in the order that you have them, and then we'll all pretty much be the same. But if you're adding, it's like if you have 2 plus 3, that's the same as 3 plus 2. So it doesn't matter. Okay, let's do some examples. We'll do the first few together. So number 26, I've got 1 square root 10, and then I've got 3 square root 10. So I've got 1 of them, and I've got 3 of them. So what do I have? I have 4 of them. Square root of 10, it's 2 times 5, and there's no pairs, there's nothing I can do, so that would be my simplified answer. Okay, number 27, square root of 20 minus square root of 5. So you might think, well, they're not the same, so I can't do anything. But if you can simplify anything, you have to do it. So square root of 20, that's the square root of 2 times 2 times 5. And then I'm going to take away the square root of 5. You cannot just take that away. Okay, you can't do 5 minus 5. So what I'm going to do is I'm going to look at this, I'm going to say 2 square root of 5 minus 1 square root of 5. So if I have 2 of something and I take away 1 of them, I'm left with 1 of them. It's like if you have 2x minus x. Okay, 28 square root of 72. So 72 is 8 times 9. So I'm going to break that down. 8 is 2 times 4 times 9. And then minus the square root of 18. 18 is 2 times 9. So if I go to get my pairs out, I'm going to have a pair of 2's and a pair of 3's, and then this 2 is going to stay in there. And then subtracting, I'm going to have a pair of 3's come out. So I have 6 square root of 2 minus 3 square root of 2. So since my radicals are the same, it's like if you have 6x minus 3x. If I have 6 of something and I take away 3 of them, I'm going to be left with 3 of them. Okay, so make sure you've studied those examples and know how they are all working. And then you should be able to go to your assignment and be able to do other examples where you use adding, subtracting, and multiplying.